We are starting chapter 7 today. You can tell we're going a little out of order. We just finished 12, so now we're jumping back up to chapter 7. Today's day 1. We're going to do day 2 tomorrow and day 3 Wednesday. So lessons all week long, but the good news is it's only a 3-day week, so you can handle it, all right? Today is all about ratios. So there's a spot in your notes to write down what a ratio is. A ratio is a comparison of two like measurements. You will not have labels in your final answer. So here are a few different ways you can write ratios. So typically you'll see ratios written as a fraction. But you can also write it in the other two ways too. So the colon, it's like 2 dots. This always makes me think of a clock. Like 2.00 would be like 2 o'clock. But anyway, the double dots with a number in front and a number in the back. Or you could use the word 2. And A and B will be numbers in these. But again, the fraction is kind of the go-to. Notice that a ratio is a comparison of two numbers. So you can't use mixed numbers. Even if you're doing it in fraction form, you have to go improper fraction. All right. Any questions or anyone need more time? All right, here is example 1. Write each fraction in simplest form. So first we're going to write it as a fraction. And then we're just going to simplify, so you can divide top and bottom by 5. And yes, you get 1 over 5. Or if you're saying it as a ratio, usually we use the word 2 in a ratio, so 1-to-5 ratio is how you'd say it. Questions? All right, here's part B. Now, this one's a little different because one is in inches and one is in feet. But remember, in a ratio, they have to be the same thing. So you can change the inches to feet. You can change the feet to inches. I think the easier one is to change the feet to inches, right? Because there's 12 inches in 1 foot. So you can just multiply the bottom by 12. That changes it from feet to inches. And then now we can reduce. All right. So 4 goes into both 16 and 36. It goes into 16 4 times. It goes into 36 9 times. And that is as simple as it gets. Bless you. All right, so once again, we have a bit of an issue with the labels. The first number is in centimeters. The second number is in meters. Do you know how many centimeters are in a meter? 100, yeah. Cent. Like century is 100 years. There are 100 cents in a dollar. So yeah, cent usually means 100. So there are 100 centimeters in 1 meter. So I'm going to multiply my denominator by 100. Now they're both in centimeters, and then I can reduce. And I have 16 over 11. All right, so in this one we're comparing days to hours. Any ideas?
Well, for like 24.
Yeah, so there are 24 hours in one day. So you can multiply the 5 by 24. So in 5 days there's 120 hours. And then you can drop your labels since they're the same, and then you can reduce. Anyone know a number that goes into both of those? 6 does. Very good. So you end up with 20 over 3. All right. Example 2 says find the ratio of wins to losses for a soccer team that played 42 games. And they won 24. All right, so it's really important when you're writing ratios to pay attention to the order. I want wins to losses. How many wins were there?
24.
24. How many losses were there?
Unknown.
18. How do I get 18?
42 minus 24.
Yeah, if you play 42 times, assuming there are no ties, if you play 42 times and you won 24 of those, that means that 18 times you lost. And then you can reduce 4 over 3. Questions? All right, example 3, find 2 numbers in the ratio 5 to 7 whose sum is 48. Ooh.
Wouldn't you do like multiples in 5 and 7 that add up to 48?
That's the basic idea. Yeah, he said multiples of 5 and 7 that add to 48, meaning like 5 times 1 and 7 times 1 and see if that adds to 48. 5 times 2, 7 times 2, see if that adds to 48. The more systematic way to do that is to define that whatever you're multiplying by as a variable.
So like,
Do you have an idea?
before, or right? Like,
Hold on, you're getting ahead of me. An unknown value in math, what do we call? An x. So I know that 5 times some value plus 7 times that same value equals 48 because it has to be an equal ratio, 5 parts to 7 parts. So I am going to let 5x equal the first number. I'm going to let 7x equal the second number. And when I add the 2 numbers together, I get 48. But yes, I think you are correct because once you add those, you'll get 12. And then when you divide by 4 or by 12, you get 4. But that's not the answer. I have to take it back. You know what I'm saying?
multiply.
So 20 and 28. And then I always check to see if you reduce that, like if you did 20 over 28 and reduced it, you better be getting a ratio of 5 to 7, and they better add to 48, or you have messed up. All right. Here's example 4. So this says the perimeter of a rectangle is 32. Find the dimensions of the rectangle if the ratio of the length to the width is 5 to 3. So I'm going to call the length 5x. Same idea. I know that I'll be increasing by multiples of 5 and by 3, right? So whatever that multiple is, I'm going to call the x. So 5x is going to be my length. 3x is going to be my width. You can go ahead and draw yourself a picture if you like. And we know that perimeter is the sum of all the sides. We usually write it as 2L plus 2W equals the perimeter. So in this case, the length is 5x. So 2 times 5x plus 2 times 3x. So yes, you are right, 10x and 6x. So 16x. What's that? X is going to equal 2, but that's not our answer. What do we have to do with that information? Yeah, put it right back up here. So my length is 10 and my width is 6. Now, notice it doesn't say like feet or inches or anything. If I don't give a label, you don't need to give a label either. You can just call it units. So 6 units by 10 units or 6 by 10 would be fine with me.
So you have to include your label in this one?
If you put units, that's great. If you don't put units, I'm not going to.
So just 10 to 6.
10, yeah. All right, example 5. A certain snack mixture is made by mixing almonds, raisins, and peanuts in a ratio of 3 to 8 to 9. How much of each ingredient is needed to make 540 grams of the mixture? Or maybe gallons of the mixture. I don't know.
Assuming that
G's. What?
Assuming that the ratio, each of them equals 1 gram per gallon. Right. Would that be assuming that
450 gallons, that's a ton
the
of food.
3 almonds equals what?
Yeah.
Is it 8?
I saw
No.
This weekend I saw 10 gallons of mac and cheese.
All right, so we're just going to write out the amounts with the ratio, okay? So 3x is the amount of almonds, 8x is the amount of raisins, 9x is the amount of peanuts. All right, and when I add each of those together, because you're mixing them together, right? You're putting them all in the same thing. All right, and then that will give us the x, and then we can plug the x back into these right here, and that'll tell us how many gallons or grams, I'm not sure what the G stands for, of each we'll need. Is grams? We'll go with grams, because 540 gallons of trail mix, I mean, that's pretty intense. That makes me want to go hiking for 10 years. Okay.
Have you seen a gallon of mac and cheese?
What?
A gallon of mac and cheese?
Have I eaten a gallon of mac and have I seen a gallon of I mean, off the top of my head, I can't recall a time when I saw a gallon of mac and cheese.
Why? I made a gallon of mac and cheese one time. That's a ton of freaking mac and cheese.
Yeah.
It's a lot of butter.
That'd be really heavy.
Why take that much?
Okay.
Because I went to a family reunion and pretty much I was just mac and cheese.
That's awesome. Okay, so we're going to go with grams. I mean, or else you'd have like the big drums of the. All right. Shh. Quit clapping. So I'm going to combine like terms on the left. 3x plus 8x plus 9x is 20x. Divide both sides by 20. X equals 27. So plug that back into each. So times 3 will give us the amount of almonds, times 8 will give us the amount of raisins, and times 9 will give us the amount of peanuts. So here are those numbers. You can verify in a calculator.
Correct.
So honestly, this works. I mean, if you wanted to make 540 gallons, you just need 81 gallons of almonds and 216 gallons of raisins and 243 gallons of peanuts. I think it's more realistic that these are grams. So we'll use 81 grams of almonds, 216 grams of raisins, 243 grams of peanuts.
Well, that's like a kid's nightmare if they're allergic to peanuts.
Yeah.
I'm allergic to almonds.
You're allergic to almonds? So if I brought 81 gallons of almonds in here, you would not be happy.
I just wouldn't be able to eat them.
Got it. All right, anyone questions? Questions, anyone?
Nope. That's the last one for today. Yeah, there's only 5.
7.7.
That's it?
Why is it so cold?
Oh, we're done?
All right, what did we learn about today? Ratios.
So fun.
I feel like I learned about peanut allergies.
And gallons.
Gallons and grams. I like these problems because it doesn't matter if it's gallons or grams, it's still the same ratios. Okay, any questions before we wrap it up? I'm going to give you your homework.
That's a lot of chocolate.